Hello, my name is Daniel Hipp, and I will be giving your guest lecture today on normative cognitive development. Before we get into the weeds of the class, I want to talk about this format here. I'll have the slides in the background, as you can see, but they might not be super easy to discern through this video. So my suggestion is, while watching this video, have your slides open next to it so you can follow along at home. Who am I? I am a neuroscience researcher now, and I've been a professor at a few different universities. My focus in research has been on developmental psychology, so indeed this is in my wheelhouse, and I'm happy to give this guest lecture today for you. Obviously, I'm not here in person for you to ask questions to, so please, if anything comes up, reach out through your instructor, and I'd be happy to get back to you. Okay. So I'm going to be talking today about normative cognitive development. And before we do this, I want to define a few terms for you that I'm sure your instructor has mentioned, but I want to make explicit at the beginning of this lecture. The first of these is developmental psychology. Developmental psychology is my field, or at least I'm close to being a developmental psychologist. I'm really a developmental vision scientist, but close enough. So this is the field concerned with how psychological processes emerge over the lifespan. Now, this may seem self-evident, but typically this field focuses on the first 18 years of life. Okay, there's no real great reason for this. It's just that 18 is kind of where we modern Americans and Western psychologists draw the line at adulthood. So keep that in mind, that part of this concept that childhood and adulthood are so separate is also partly culturally constructed. It's not, in other words, essential. So developmental psychologists, among other things, are really experiment constructors. That is to say, they design experiments, especially when it comes to infants, that are designed to elicit responses the infants otherwise aren't smart enough or developed enough or motorically capable enough to give themselves. You can't, for instance, go up to an infant and ask them what they think of something because they can't respond to you. So you have to come up with good tricks to figure out how to probe their minds. And this isn't always so easy. So keep in mind when we go over the various facts about development today that very tricky and clever experiments underpin these. So that's how we came to this sort of base of knowledge. Okay, so that's developmental psychology. What about the title of our lecture today? Normative cognitive development. Now, I'm using the word normative here to differentiate from clinical development. That is to say, our abnormal psychology development. That is to say, what we're talking about today is the basic, typical, let's call it normal, in the statistical sense, track through the lifespan that a psychology characteristic takes. So if we had something like language learning, which we'll spend some time discussing today. Obviously, infants don't start with the ability to speak full sentences, and yet most adults you meet, without some psychological condition preventing this, are able to speak full sentences, and in fact listen to them and construct whole thoughts, as I'm attempting to do right now. So they have to get that way somehow, and what we do when we study normative cognitive development is we try and understand the average path taken through the lifespan. Okay? Now, sometimes I use the analogy to the metaphor that these things come online at some point. It's not exactly true. It's not the best metaphor, but it's going to guide us, I think, today. So if I fall back into that way of speaking, forgive me. Okay, so obviously there is no normal human, right? I'm not normal. Nobody's perfectly normal. Normal is the perfect statistical average. So when we study normative development, what we typically do is we study a lot of children or adolescents or infants or even adults, and we figure out what's happening on average with them. That is not to say that we scientists don't understand that there are normal variations from the average. Okay? So, of course, everything I say today, there will be caveats that come to mind, and that's good. That means that you're being thoughtful about the content of today's presentation. But don't come to the conclusion, therefore, that we scientists don't understand this ourselves. Studying normative development does not reject the studying of individual differences or variations between groups and things like that. However, we have to start somewhere, and being that this is an introductory course, we're going to skip a lot of that variation today and sort of go for the mean or the average. Okay? All right. So, I mean, adults are really good at lots of things. Think about what it takes to get through your typical day, an average day in your life when things don't go horribly wrong or anything like that. You have to get up and navigate a three-dimensional environment. You have to speak these complex sentences to other people, even to get a cup of coffee in the morning. You need to be able to find objects in your environment. And although many of these things seem incredibly intuitive to us, it is not the case that we come pre-built and able to do these from the start. Many of these capacities that we consider trivial or everyday sorts of things are underpinned by a great deal of complexity and development, in which these things, again, I'll use the phrase, come online over time and assume their mature form over many, many years. Okay? So, there's really two ways that we can describe how something in human psychology gets that way. Gets the way it is. As your professor has noted, this is the kind of nature and nurture debate. Is something an evolved adaptation to help us move around the world, or is it purely learned or developed? None of those are ever the case. It's always a little bit of both. And today we're obviously, because of the nature of the lecture, going to focus on the development or nurture part of things. That is not to say that the evolutionary level of analysis is invalid. It is completely valid. It is just a different way of thinking about the same things. So if I was talking about the evolution of the visual perception system, let's say, doing so would not invalidate the fact that infants are born with an incomplete visual system that needs to develop over the lifespan. And in fact, some psychologists discuss developmental programs that evolve, not just features of the mind and brain. It is that ways of hitting all the different milestones over developmental time are what gets evolved. We're not going to dive into the weeds on that today. We're just going to focus on development. But I wanted to bring this up to highlight the fact that these are just complementary explanations, and to be a developmentalist does not mean that you reject an evolutionary explanation, and to be an evolutionist does not mean you reject developmental explanations, at least with the best researchers. Okay. So, what actually develops? Well, we psychologists love to carve things into neat little categories. This is perception, this is cognition, this is emotion, and yet, of course, the brain is not carved into these categories. There are regions that do more perception than other regions. There are regions that do more high-level cognition than other regions, but that is not to say that these are isolated processes. So it's important also, and I know I'm throwing a lot of caveats at you before we get into the meat and potatoes here, but it's important to remember that these things aren't truly separate in the mind and brain. Okay, hopefully I can highlight a few of those non-separations as we move forward here. So here's what we're going to do today. This is a rough outline. We're going to start with the perceptual starting point. Where do infants begin their lives in terms of visual perception in particular? Now, I'm a vision scientist, so I will be focusing on vision, but that is not to say there aren't great parallels with the auditory system, with touch, with movement, with taste. We, though, are visual primates. We have these big eyes right in the front of our heads. We have a huge chunk of our brains dedicated to vision, and indeed, most primates are more visual than other animals. Dogs, for instance, aren't as visual as primates. Rats aren't as visual as primates. And we are some of the most visual primates there are. Not just because our eyes are great, but because our brains have all these little visual regions that do mostly visual stuff, and they do it in these very complex ways that builds up this beautiful world we see around us. So